Take a look at a handful of poems and try to guess which ones were written by a human and which were generated by a machine. It sounds like an easy challenge. The results from researcher Oscar Schwartz's experiments are incredibly difficult to predict. When an algorithm is trained to mimic Emily Dickinson, it reliably spits out Dickinson-flavored language, rhythms, and patterns that easily trick readers into believing a person wrote them. Modern algorithms are good forgers, but even rudimentary systems like Racter, a poetry program built back in the 1970s, fooled a surprising number of people. When Schwartz showed his audience a genuine poem written by the famous human author Gertrude Stein, most of the room incorrectly flagged it as AI-generated text. They didn't reject her work because it was poorly written. They rejected it because it was fragmented, unconventional, and weird. It lacked the tidy, predictable structure we typically expect a poem to have. This dynamic creates what Schwartz calls a reverse Turing test. Instead of evaluating whether a machine can successfully pass as a person, the test actually exposes our own narrow assumptions about creativity. We expect human expression to follow a recognizable, predictable pattern. When a poet breaks those rules and produces a different kind of human sound, we fail to recognize the humanity in it. We see this difference in a visualization of blocks representing poetry stanzas. AI-generated poems default to mechanical symmetry, while human writing leans toward asymmetrical, messy instinct. As the structure here shows, the machine simply reflects and remixes the organic dataset it was originally fed. If these algorithms function as highly advanced mirrors for pattern recognition, we can point that processing power at existing text instead of generating something new. Applying computational data processing to classic literature allows us to uncover the subconscious structural habits that authors left behind without even realizing it. This approach is a core part of Digital Humanities, utilizing tools like the CLiC Concordance, software that rapidly searches massive text databases to examine novels like Charles Dickens' David Copperfield. We can use this software to track exactly how Dickens constructed one specific supporting character named Mr. Dick. To a human reader skimming the text, he appears as a regular participant in the dialogue. His narrative function easily blends into the background. But this visualization tells a different story. Filtering the text to separate Mr. Dick's dialogue from the narrator's descriptions isolates his exact linguistic patterns. Reorganizing this into a cluster graph reveals a massive concentration of passive verbs. He's overwhelmingly a receiver of actions. Dickens characterized him through facial expressions, through subtle body language, and responses to the surrounding world, rather than through direct physical action. Human reading biases train us to glide right past these repetitive narrative cues, leaving a deep psychological characterization pattern completely unnoticed until the algorithm caught it. So do these computational tools make the traditional human reader obsolete? The reality is a new division of labor. The software's only job is to sift through millions of words and surface the invisible mathematical evidence buried inside the text. It is still entirely up to the human reader to look at that cluster of passive verbs and interpret what they mean for the story, the culture, and the character's psychology. As the text generation we saw in the poetry experiments continues to improve, the dividing line between human and machine writing will only become harder to spot. Navigating an algorithmic age requires us to slow down. We have to stop skimming pages for a general feeling and start observing the text with deliberate, microscopic attention. Digital tools don't replace our creativity. They act as algorithmic mirrors, challenging our biases and forcing us to constantly redefine what makes our writing human.